We're going to use the law of conservation of momentum, the law of conservation of energy, and the law of cosines to solve a conservation of momentum problem. Law of cosines is handy, but we need to understand what it says. So the law of cosines is true for all triangles. It's basically an extension of the Pythagorean theorem to all triangles instead of just right triangles. So I'm going to label this triangle has vertices A, B, and C, and then it has sides, opposite sides of lowercase letters. So opposite angle A is side A, opposite angle B is side lowercase b, and then opposite side C is side lowercase c. Law of cosine says a squared plus b squared minus 2ab cosine capital C equals c squared. Essentially what it says is the sum of the squares of the two sides of a triangle minus the product, twice the product of those sides, times the angle between them, the cosine of the angle between them, is equal to the square of the third side, right? So law of cosines is essentially a Pythagorean theorem for all triangles instead of just right triangles, right? Because if this angle was a 90-degree angle, the cosine of 90 is 0, then this becomes a squared plus b squared equals c squared. Okay, so here's the problem. I have a 1.4 kilogram ball that's initially moving this way at, say, 2.8 meters per second. And it strikes a 1.8 kilogram ball that is initially at rest. As a result of this perfectly elastic collision, ball A moves up at 30 degrees to its original trajectory. I want to know the final speed and direction of balls A and B. So I want to know VA and I want to know VB after the collision. Now, the reason the law of conservation of momentum and the law of cosines is handy for this is because I know something. I know the law of conservation of momentum says the total momentum before and the total momentum after is the same. And I know the total momentum before. The total momentum before is all in the x direction, and it's 2.8 times 1.4 because momentum is mass times velocity, and 2.8 times 1.4 is 3.92. So I know the total momentum before the collision is 3.92 kilogram meters per second. Now, the best part about that is I know that the two vectors that are left afterwards have to add up to that. Vectors, remember, they don't care where they are in the plane. And so vector A, which is this one, I actually know that angle. It's up like this. It has velocity VA and it has mass, the ball didn't change mass, of 1.4 kilograms. And I know this angle is 30 degrees. Like, well, why is that helpful? Well, if I know that vector, I know that the vector for ball B has to, vectors are added tip to tail, has to add up with that vector to be what it started as. So this is VB times its mass, which is 1.8. Now, the reason I like this is because this triangle right here, even though it's not a right triangle, I can use the law of cosines on it so I can find a relationship between VA and VB and this number I have down here. Now, I'm still going to need another equation because I have two unknowns, but this allows me to, instead of using x's and y's and using components, I can do this in one equation. And so a squared plus b squared equals c squared, or a squared plus b squared minus 2ab cosine c equals c squared. And so on this, we'll write the law of cosines. We'll write, okay, so let's make this side A and this side B because the angle between them, and so this is side C. And so a squared is VA times 1.4, and this whole thing gets squared, plus b squared, 3.92 squared, minus 2ab, so minus 2 times, let's grab this thing and move it to where I'll have enough room, and then minus 2ab, so minus 2 times VA times 1.4 times VB, which is 3.92, times the cosine of C, well, that's 30, equals C squared. Now remember, C squared is actually VB times 1.8, its mass, and then this whole thing is of course squared. And we'll simplify that in just a minute. Actually, we'll go ahead and simplify that now. So 1.4 squared is 1.96. So I have 1.96 VA squared plus 3.92 squared is 15.3664. 15.3664 minus 2 times 1.4 times 3.92 times cosine 30. And so 9.5 VA equals 1.8 squared, or 3.24 VB squared. All right, so there's my equation, two unknowns. I don't know VA, I don't know VB. However, I do have the law of conservation of energy. This was perfectly elastic collision, so I know that 1/2 mass A times velocity A squared initially, and so I should write a not on that, equals 1/2 mass object A times final velocity object A squared plus 1/2 mass object B times final velocity object B squared, right? That's conservation of kinetic energy, since this is a perfectly elastic collision. There's a half in every term, so we'll divide it out. We actually know MA, right? So this is 1.4, and we know VA naught times 2.8 squared. So 2.8 squared equals MA 1.4 times VA squared plus, and then I have MB, which is 1.8 times VB squared. Now, 2.8 squared times 1.4 is 10.976. 10.976 equals, and over here I have 1.4 VA squared plus 1.8 VB squared. What's handy about this is I can solve this equation for VB squared. VB squared is equal to 10.976 minus 1.4 VA squared all over 1.8, right? So 10.976 divided by 1.8 is 6.097, so VB squared equals 6.097, and then 1.4 divided by 1.8 is 0.77 forever, so minus 0.78 VA squared. That's VB squared, which means I can put it right there, and I can say, okay, 1.96 VA squared plus 15.3664 minus 9.5 VA equals 3.24 times, and instead of VB, I'm going to use 6.09798 actually, minus 0.78 VA squared. And then I just need to combine like terms, and so 3.24 times 6.098 is 19.75, so equals 19.75 757 minus 0.78 times 3.24 is 2.527, so 2.527 VA squared. And I still have the left side. Now I'm going to go ahead and add that over, so plus 1.96 to get my VA squared together, and I have 4.48 VA squared, and then I have this minus 9.5 VA, minus 9.5 VA, and then I have plus 15.3664, and I'm going to have to subtract this 19.75, so 15.3664 minus 19.757 is minus 4.39. Minus 4.39 equals 0. That is a quadratic, right? And so I can just solve the quadratic, and our A term is 4.48, our B term is negative 9.5, and our C term is negative 4.39. And when we do that, we get two answers, we can have VA is equal to 2.51, or it's equal to negative 0.39. Okay? And so then we have to decide which one of those is the correct answer. We know it actually has to be the positive 2.51 because of the way we drew our picture. If it was the negative 0.39, that would imply to us that this was going the other direction, and we know it is not because we were told in the problem that it was at this 30 degrees above its initial path, not 30 degrees below. I guess that would be 150 degrees below its initial path. And so now, since I know VA, I can also find VB. I do have right here that VB squared is equal to 6.097 minus 0.78 VA squared. So I'll take my 2.51 squared, multiply it by 0.78, take 6.097 minus that, and square root that answer, and get 1.09. And so VB equals 1.09 meters per second.